A small town in Ohio commissioned an actuarial firm to conduct a study that modeled the rate of change of the town's population. The study found that the town's population, measured in thousands of people, can be modeled by P of t equals negative 1/3 t squared plus 64t plus 3,000, where t is in time in years. So A is asking us to use the definition of the derivative to find p prime of t. All right, write down that definition here. P prime of t definition is the limit as h approaches 0 of p of t plus h minus p of t all over h. It's the same difference quotient formula. I just replaced the function name f by p, and usually we use the letter x for our input variable, right? But this one is using t, so I just changed that to t instead of x. So let us find the difference quotient and simplify it. After that, we're just going to plug in h equals 0. Okay? All right, so difference quotient work now. The difference quotient will be all over h. But first thing we will need to do is plug in t plus h into this function. So look what that's going to be. That will be negative 1/3 times t plus h squared plus 64 times t plus h plus 3,000. So what I wrote down in orange is this orange highlighted part. Let's continue with the numerator. Minus sign. And after the minus sign, I need to subtract the p of t, which is just this entire function. So I'll write parenthesis negative 1/3 t squared plus 64t plus 3,000. My fraction is not long enough, so let me extend this a little bit. All right. So the numerator, we're going to have to do some simplifying there. So I will just jump into it. All over h, right? This first, this t plus h squared, we know that is t squared plus 2th plus h squared. So that expansion of binomial squared keeps coming back, so it's easy if we just kind of get it memorized. Let's distribute this 64 to t and h. That is 64t plus 64h. Now bring this 3,000 down, plus 3,000. All right, let us distribute this green out. So when you distribute, you know what, I'm not going to, maybe I'll use a red. If you distribute this negative sign in front of this, everything in this green parenthesis will switch the sign. So this negative 1/3 t squared will turn into plus 1/3 t squared. Plus 64t is now minus 64t. Plus 3,000 is minus 3,000 now. All right. I need to distribute this 1/3 that is in front of this yellow highlighted trinomial. That is going to give me, 1 second, negative 1/3 t squared. Now, if I do, 1 second, I'll do this. If I do negative 1/3 times 2, you agree that's going to be negative 2/3, right? Negative 2/3 TH. And then now multiply this negative 1/3 to this T squared. That will be minus 1/3 T squared. All right, I'm done distributing this. All right. So what's next? Copy down the rest of this numerator. I'm using my iPad so I can just like literally copy that down here. Okay. And all over H. Oopsies. Let me do this again. Duplicate it down here. And these are all over H. And we will be able to cancel out a lot of these terms on the numerator. So let's see what goes away. There is negative 1/3 T squared. And there is positive 1/3 T squared. Those are gone. What else? There's positive 3,000 and there is negative 3,000. They're opposite, so they're gone too. There's 64T. There's negative 64T. So those are gone. So let's write down the leftovers. You know, I may have to make my work a little bit smaller so that I can have some more room here. All right. So what's left on the numerator is negative 2/3 TH minus 1/3 H squared plus 64H all over H. And notice all of these terms on the numerator has H, right? So we're going to factor out that H to the front. If you bring out the H to the front, the inside will become negative 2/3 T minus 1/3 H plus 64. And we can now cancel out that H that is on top and bottom. Oh, where did that H go? I was going to cross it out. And now we have the simplified difference quotient. The whole thing turns into negative 2/3. You know what? I'm not going to write it again. Let me just copy and paste it. All right, so that's it. That is what survived. Okay. Remember, that's just the difference quotient. Now what we need to do is to find P prime of T. We need to evaluate the limit. Limit as H approaches 0 of this expression. Okay? So we need to now plug in. Let me just go zoom in right here. After finding the simplified difference quotient, you need to plug in H equals 0, and that is P prime of T. So let's do that. So if I plug in T equals 0, where is H? H is right here. So that will turn into negative 2/3 T times 1/3 times 0 plus 64. 1/3 times 0 is just 0. So here's our P prime of T. P prime of T is negative 2/3 T plus 64. And that is how we can use the limit definition of derivative to find P prime of T. If we were to use the power rule, that would have been about 1 minute problem, okay? But now we have this P prime of T, you can use this to find, well, C. I'm going to stop this video and start another recording to go over B and C shortly.